We're in Rosen 3.3 studying the complexity of algorithms, and I want to work a couple of homework problems so that you'll see how we can use the function for the number of operations to find out how big a problem we can solve in a given time. So I'm looking at 17, problem 17 in 3.3, number B. And in this case, the function that gives us the number of operations for problem size n is log of n. Time is 1 minute or 60 seconds. And we have 10 to the minus 12 seconds per operation in this computer. All right, so now first thing we want to do is get Fn to give us the amount of time it takes to solve a problem of size n. So Fn is equal to log n operations times 10 to the minus 12 seconds per operation. So operation cancels out, giving us 10 to the minus 12 times log of n, and this will be seconds to accomplish that task. Well, then now I want to know how big can n be and still solve a problem in less than 60 seconds. What we'll do is we'll set this expression equal to 60. What n makes this expression equal to 60 seconds. Well, we'll just set them equal and solve for n. We can get rid of the seconds. We say 10 to the minus 12 log n is equal to 60. We'll multiply both sides by 10 to the 12. Log n is equal to 60 times 10 to the 12. And to find n, this is a log base 2. We'll raise both sides to the power of 2, and we get n is equal to 2 to the 60 times 10 to the 12, which is a really, really large number, of course. So let's look at number E. So it has the number of operations to solve a problem of size n is n squared. And again, t is equal to 60 seconds. All right, well, instead of getting the number of operations for problem size n, let's recouch this as time. So Fn equal n squared operations times 10 to the minus 12 seconds per operation. Operations cancel, giving me n squared times 10 to the minus 12 seconds. All right, well, similarly, how big can n be and still stay underneath 60 seconds? We'll set it equal to 60 and solve for n. So n squared times 10 to the minus 12 seconds equals 60 seconds. Seconds cancel, solve for n. We get n squared equals 60 times 10 to the minus 12, times 10 to the 12. And then we'll take the square root of both sides. And since this is likely to have a fraction, we'll take the floor function because you can't have a fractional number of integers in a problem size. And if you go above, then it'll go more than 60 seconds. So we'll say that n is equal to the floor function of the square root of 6. Oh, I'm going to erase that. Of 60 times 10 to the 12. And that equals 7,745,966. Okay, so that's how you find how big a problem you can solve in a given size, knowing the given information.